Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is the last video on the chapter of physical quantities and measurements. This is regarding uh, a very interesting formula that using which we can find the relative density of a solid body which is denser than water at 4 degrees centigrade. So using the fact of apparent weight or the weight lost by a solid body denser than water at 4 degrees centigrade, when it is immersed, we can find its relative density. So this video is part of the playlist ICSE Physics for Class 8, where I primarily discuss about key concepts and formulas related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 19 video, where I will discuss about a formula to find the relative density of a solid body which is denser than water at 4 degrees centigrade. Okay, so this is the situation. Sorry, there is a solid body having density rho1 and not liquid. Actually, sorry, this will be the liquid is actually water, which we know. Let's say, okay, the density of water at 4 degree centigrade. Even though we know that the density of water at 4 degrees centigrade is 1 gram per centimeter cube, let's denote it with rho2. Now, it is a known fact that the body is denser than water at 4 degrees centigrade, meaning rho1 is greater than rho2. Now, in this scenario, the figure I have drawn is wrong. We know that when a solid body is denser than a liquid, it sinks. It sinks. So, the diagram should have been like this. The diagram should have been like this. So it sinks. It sinks. So this is it sinks. But still, due to buoyancy and Archimedes Principle, we know that the weight of the body is acting vertically downwards, and the buoyant force or the upthrust is acting vertically upwards on the body. Okay. Now, in the problem, the weight of the body will be given, that is W will be given, and the apparent weight will be given, or the buoyant force will be given. Either, so what is the apparent force? The apparent weight is W dash is nothing but W, its own weight, that is the weight in air, minus the buoyant force. This is the apparent weight of the body when denser than water at 4 degrees centigrade, when it is completely immersed, it has sinked. Okay, now let's say we are given the apparent weight, that is W dash is given. W dash is given and W is given. So let's say case 1, let's say given let's say W is given, that is the weight of the body, and the apparent weight is given, that is when it is, since it is denser than water at 4 degrees centigrade, it will be completely immersed, it will sink, and inside the water the apparent weight W is given. So W and W dash is given, and we have to find the relative density of the body. Basically, we have to find rho1. How do we find rho1? Okay, now from okay, so from W and W dash, I can find the buoyant force. Buoyant force will be W minus W dash. That is the weight of the body, normal weight of the body, that is the weight of the body in air, minus the apparent weight. In the apparent weight of the body inside the water at 4 degrees centigrade. Okay. Now, to find the relative density, we know that the relative density of the body is nothing but the mass of some volume of the body divided by the mass of equal volume of water at 4 degree centigrade. Since we are considering the liquid to be water at 4 degrees centigrade, what is the buoyant force? What is the buoyant force? Since the body is completely, the body is, has sunk, so it is completely immersed in the water. So the volume of the buoyant force, which is the weight of the displaced liquid, not in this case it is water, it will be V, that is volume of the body, multiplied by rho 2. Rho 2 is nothing but the density of the water at 4 degrees centigrade, which we know is 1. This is the mass of the displaced liquid. This much gram force. So mass of the displaced liquid, mass of the displaced liquid, or mass of the V volume of water at 4 degrees centigrade is V rho 2. Okay. Now, what is W? W is the volume of the body and its density. This much V into rho 1 is the mass of the body. This much gram force is the weight of the body. So clearly we can see that relative density of body is what? Is equal to mass of some volume, let's say V of body, divided by mass of the same volume, mass of volume V of water at 4 degree centigrade. Now, if we consider the volume of in this formula, if we consider the volume V to be the volume of the body, then its mass will definitely be V rho 1. V rho 1 is its mass. Okay, and divided by mass of volume, V volume of water at 4 degrees centigrade, which is V rho 2, which is V rho 2. Now this is equal to, we can say V rho 1 is W. V rho 1 is W. And what is V rho 2? V rho 2 is FB, which is W minus W dash. So this is the formula for finding the relative density of a body which is denser than water at 4 degrees centigrade when we are given the weight of the body in air and its apparent weight when it is immersed in water at 4 degrees centigrade. Okay. Now, if instead of W and W dash, if we were given W and FB, then directly we can see that this is nothing but W by W minus W dash is FB. So this is basically the formula of finding the relative density of a body which is denser than water at 4 degrees centigrade. Relative density of body, I can say, whose density is greater than 1, because density of water at 4 degrees centigrade is 1 gram per centimeter cube, is equal to, I can say that the weight of the body in air divided by the apparent weight of the body in water at 4 degrees centigrade, or it is also equal to W by the upthrust or the loss in weight. Please remember that FB is the loss in weight. The apparent weight W dash is W minus FB. So from the weight W, so the FB is nothing but the loss in weight of the body in water. So this is also equal to FB. So if we are given W and FB or W and W dash, we can easily find, using this formula, we can easily find the relative density of the body. But please keep in mind that this formula will work only when the density of the body is more than the density of water at 4 degrees centigrade. So this was a very short video. I wanted to discuss an interesting formula to find the relative density of a body denser than water at 4 degrees centigrade when its weight in air and apparent weight in water at 4 degrees centigrade is given. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will start a new chapter. I don't know which one. Let's see. So please stay tuned for upcoming videos. Thanks for watching, and until the next video, take care and bye.